Hello everyone, in this lecture we will adjust our camera for all types and sizes of screens. At this point the camera size is good, but on a different mobile device maybe it will be too big or too small. To solve this problem we use Cinemachine and a virtual camera. So let's import the Cinemachine package, go to Package Manager and select Unity Registry. Find Cinemachine and install it. Now let's create a virtual camera. You can reset the transform component and set the z-axis to a negative value. In that way, we make sure that the objects are in front of the camera. Notice that now we control the camera size on this virtual camera. Idea is to create two empty objects on the side edges of the screen and then make sure that those two objects represent the edges of the camera regardless of the device. So they always need to be inside the camera view and act like edge boundaries. Let's create a new empty game object. I will call it a left point. We can give it an icon. Then reset the transform component. Move the object to the left. I think that -4 is a good value. Don't go all the way to the edge. Then duplicate the object. This will be right point. The value for x needs to be symmetrical, so it's 4. Now we need a new empty game object. Call it target group. Reset the position. Then we can add the script from the Cinemachine package. Add the Cinemachine target group script. You can see that we can add target objects to the list. We need two targets. One is left point and another is right point. Great. Now select virtual camera. Drag the target group into the follow and look at fields. Since we are using a group of objects, for the aim, select Group Composer. We need to change a couple of options. The first one is Group Framing Size. It defines how much screen space is taken up by the bounding box of the targets. We need to set it to 1 so that the edges of the screen are exactly on left and right points. Then set Frame Damping to 0. The lower value, the faster camera will adjust itself to the correct size when the level starts. Now you can try it in the simulator. Change devices and see how the game looks. It should be fine. However, there is one hidden problem. Notice that movement restrictions are not working correctly anymore. The reason is that we set restrictions in the start function, but the Cinemachine didn't have time to set the camera correctly at the start of the level. So the viewport from which we get coordinates sends wrong data. The solution is quite simple. We can use coroutine. With coroutine function, we can delay the execution of code. The syntax is a little bit different. We need to create the IE numerator function. In the function, the code is kinda separated into two parts. In the first part, we do something or nothing, depending on what we need, in this case nothing. Then we add time delay. We write yield return new and then choose how long the delay will be. For example, we can wait for end of frame, we can wait for certain amount seconds, and so on. Let's wait for 0.2 seconds. After time passes, we execute the second part of the code. In this case, we need to get restriction values. Those 0.2 seconds is enough time for Cinemachine to adjust the camera, and then we get the correct viewport data. Actually, let's use wait for end of frame for this example. We expect that one frame is enough time to adjust the camera. The last thing, we need to call this function with start coroutine. Use start coroutine in the start and call the setBoundaries function. Let's try it now. Everything works fine. Note that sometimes Cinemachine needs more time to adjust the camera, for example on older mobile devices, so maybe it's smarter to have more time delay. That's it, I hope you understood everything and see you in the next lecture.